Hello everyone, hi, good afternoon. I am Rahul Mohnani, your maths educator. I hope your audio video is everything clear. Okay, so if anyone is willing to take the plus subscription, they can use my code RMSIR for taking the plus subscription. And for Iconic also you can use the same code RMSIR. So for ISC 11th and ISC 12th, you can use my code RMSIR to enroll for the new course. In today's session, we'll study Algebra of Vectors, and the major topic is vectors. Just let me know the audio video is okay or not. Okay, fine, it is okay. So I just wanted to inform you that we have started a batch from 6th of October, and these are the educators who will be covering all the subjects. So to enroll this batch, you have to join the plus, and for plus you can use my code RMSIR to subscribe it. Okay. Now let's start with the topic of vectors. Like in this, we'll learn algebra of vectors. What does it includes? Let me add those topics over here. Like we'll learn how to add two vectors, addition of vectors, how to subtract, third, dot product of vectors, and the fourth, cross product. These are the some basic algebraic operations we'll be covering in this chapter, in this particular video. Addition of vectors, subtraction of vectors, dot product, cross product. Okay, these are the major. Along with that, we'll try to cover the application of dot product and cross product also, like where exactly it is used and what are the application of addition and subtraction also, how to find the diagonals and everything. So we'll go step by step. We'll start with the addition of two vectors. Addition of two vectors. For example, let's say we have a vector 1 which is 3i. Let me just write over here, which is 3i minus 2j plus 5k. Vector 2 is 4i plus 6j minus 3k. This is the vector, a given vector, right? And for example, they have asked you find the addition of these two vectors, v1 plus v2. So here you just need to add the components of I, like 3i plus 4i, that becomes 7i. Add the I components, add the j components, like minus 2 plus 6 is 4j, and then 5 minus 3, which is 2k. So adding the components of I, j and k, corresponding components, we'll get the resultant vector, and that vector is the summation of the given two vectors. That vector is summation of the given two vectors. I think it's very simple. You just need to add the corresponding coefficients. Okay, now where exactly we can use this? So let's try to understand that part also. When you have a two given vectors of a triangle, let's say A, B and C, and you have been given AB vector. Okay, you have been given AB vector, which is 4i minus j plus 2k. Okay, this entire AB vector is given. Then AC vector is, let's say, given. AC vector is 5i plus j minus 3k. And they have asked what is the BC vector. They have asked what is a BC vector. Okay, so in this case, like, we should know the triangle law or triangle property. I'll write that property over here. AB plus BC plus CA vector, the sum of all this is 0. Okay, AB plus BC plus CA vector, the sum of all this is 0. So from here, BC vector is equal to minus of AB vector plus CA vector, minus of AB vector plus CA vector. So now we have AB vector here. Now we have a AB vector, which is 4i minus j plus 2k, and CA vector we don't have. So to find the CA vector, we need to take a negative of this part. We need to take the negative of AC vector. So AC vector is given, but we need CA vector. So that is what exactly negative of the AC vector. So let's write the CA vector over here. CA vector. So instead of 5i, I'll write minus 5i. Instead of plus j, I'll write minus j. Instead of minus 3k, I'll write plus 3k. So this is nothing but the CA vector. So BC vector is minus of AB. AB is 4i minus j plus 2k plus CA vector. Now here plus CA vector means minus 5i minus j plus 3k. This is the part where we are going to use the summation of two vectors. This will help us to find the third side of a triangle. And along with this property, this is also called as triangle law. Okay, or a net displacement law. Like, if you are moving from A to B, then B to C, then C to A, the net displacement is 0. I hope this is clear. The net displacement part comes over here 0. From this you can find the BC vector. Let's write that also. So 4 minus 5, which is minus I, then minus j and minus j, it becomes minus 2j, then 2k plus 3k, it becomes 5k. Again you multiply this minus inside, you will get I plus 2j minus 5k. This is what we are getting. Okay, so it's a very basic operation, very basic thing to add the two vectors. Now let's go ahead with the next part, which shows us how to subtract the two vectors. It is similar to addition of two vectors only. Subtraction of two vectors. Okay, now let's say we have been given vector 1, which is 4i minus 5j plus 2k, vector 2, which is I minus 3j minus k. Okay, we have been asked what is v1 minus v2. What is v1 minus v2? So in this case, when you subtract, like, you have to subtract the corresponding components of I, j and k. So 4i minus I will be 3i, minus 5i minus of minus 3j, it will become plus, like minus 5j minus of minus 3j. This part will become plus. Similarly, 2k minus of minus k. Okay, so initially I directly subtracted over here. So 3i, this will become minus 2j, and this will become 3k. So this is a vector v1 minus v2. This is the vector v1 minus v2. A new vector is created by subtracting the given two vectors. Okay, a very basic operation again on vectors. Now where exactly we are going to use this? Before an application, we'll just understand the concept of parallelogram when two adjacent sides are given. So I want everyone to note this. In a parallelogram with the two given vectors a and b, vector a and vector b, this diagonal which is generating from the two vectors is mentioned as a plus b vector. A vector plus b vector, this diagonal, and the diagonal which is not passing through the intersection, like this one, let's say this is a, this is b. Okay, so this vector, this will be b minus a vector. Like, it depends upon the direction, it can be a minus b also, right? So to understand this better, like, let's name this as a b c. Okay, so we are going from c to a, we are going from c to a, this direction I have written, c to a. So from c to a we can go like this also, right? C to b, c to b, and then b to a. This is the direction, c to b and then b to a. So here it is minus b, c to b means what? Minus b, and b to a means plus a. So this is actually a minus b. Well, there is this. This is how you understand which logic we are going to apply. This is a minus b. Again, try to understand CA vector. CA vector is what? A minus b. How it came? To reach C to A, focus on the direction. To reach C to A, we can go from C to B, this, and then from B to A, this, then from B to A. So C to B is a minus B vector because I have made this arrow like this. So BC vector is B. In that case, C to B is minus B. We are going opposite to the B. And then B to A is a vector like this. I hope everyone is clear with this. Minus B plus A, or A minus B. So in some of the questions they can ask you, like, let's write the question itself. Find the length of diagonals of parallelogram. Find the length of diagonal of parallelogram whose adjacent sides are given by the vectors. Given by the vectors. A vector as I minus 2j plus 3k, and B vector as 4i minus j plus 2k. Okay, this is the B vector. So these are the adjacent vectors given. These are the adjacent vectors given to us. So it is asked what are the length of diagonals. So let's say these two are the given vectors, vector A and vector B. So one of the diagonal D1 is given as A vector plus B vector. Just a minute. And the other diagonal D2 is B minus A. This one is B minus A, and the other one, let me draw with a different color. This one is A plus B. So let's find the A diagonal one first. A plus B. A plus B is 5i okay, 5i, and then minus 3j, then 5k. This is diagonal 1. Diagonal 2 is, let's write at B minus A. So while writing B minus A, 4i minus I. 4i minus I is 3i. Minus j minus 2j. So plus j. And 2k minus 3k minus k. So these are the two diagonals, but we have asked the length of two diagonals. It means the magnitude is required. So magnitude of diagonal 1, it is root of 5 square is 25, minus 3 square is 9, and then 25. It is root of 59. So the diagonal 2 length is root of 9 plus 1 plus 1, root of 11. These are the two required lengths. I hope this is clear till now. Whatever we have learned till now, hopefully this entire part is clear. Fine. Now I think we have done with the addition and subtraction, where we can use this to find the side of a vector if two sides are given or two vectors are given in a triangle. Okay, if two sides vectors along the two sides are given, then vector on the third side can be easily obtained by the addition law. Then after that, subtraction of two vectors will be helpful in many other different questions. Okay, now let's go ahead with the dot product. Dot product of two vectors. In this, let me take an example or a node point. Let's write a node point. Let's say there is a vector 1, which is a1 I, a2 j, a3 k. There is a vector 2, b1 I, b2 j, b3 k. Now we need to find v1 dot v2. So whenever dot product is required, you just need to multiply the corresponding components of I, then add it with the corresponding component of j, and then with k. So here a1 into b1 plus a2 into b2 plus a3 into b3. This is what the value of dot product is. It's a scalar value, so we also call it dot product as scalar product. We also call it as scalar product because the value obtained is a scalar quantity. It's not a vector. So we say that v1 dot v2 is a1 b1 plus a2 b2 plus a3 b3. This is the way we find out dot product of two vectors. Okay. Now let's take an example. v1 vector 3i minus 2j plus 5k. Okay, and the other vector v2 is I plus j minus 3k. So let's write v1 dot v2. 3i into I is what? 3, because here it is 1, minus 2j plus j, it is minus 2, or minus 2 into 1, let's write it. Then 5 into minus 3, like this. So 3 minus 2, this is minus 15, it becomes 3 minus 17, which is minus 40. So it's a very basic kind of question in which you have to just multiply the I components, okay, then the j components, then the k components. Now let's see where we can use this, or let's understand the further node points of this dot product. So a dot b is actually defined as mod a into mod b into cos theta. Okay, so from here we can say that a dot b is helpful or can be used to find the angle between two vectors. Okay, this logic is used. If A dot B is negative, then we say theta is an obtuse angle. Okay, if A dot B is positive, then we say theta is acute angle. And if A dot B is 0, we say that theta is 90 degree or right angle. This is a very important definition of a dot product. A dot B is mod A mod B cos theta. Okay, so if A dot B becomes negative, as in the previous case we saw A dot B was negative, so the angle between these two vectors, was obtuse angle. Okay, now let's use it somewhere to find the angle between two vectors. Let me just write it in the next page. Find the angle between two given vectors. Okay, vector 1 is I minus 2j plus 2k. Vector 2 is 2i minus 2j plus k. Okay, 2i minus 2j plus k. So first of all, let's find the dot product within two vectors, v1 dot v2. So I component is 1, here I component is 2, plus I component in j component in this minus 2, and here also minus 2, plus k component is 2, and also here 1. So it becomes 2, this plus 4, then 2. Total becomes 8. So now the cos theta. Before again finding cos theta, let's write the mod of v1. What is the modulus of v1? It is quotient of I square, that is 1 square, then minus 2 square, that is 4, and again 2 square, that is 4. So it becomes 3. Similarly, mod of v2 also becomes 3. So 4 plus 4 plus 1, 3. Fine. So cos theta is v1 dot v2, upon mod of v1 into mod of v2, so which results into 8 upon 3 into 3, which is 9. 8 upon 9. So the angle is what? Angle is theta is equal to cos inverse 8 by 9. This is how we use the dot product to find the angle between two vectors. In this case, the angle is cos inverse 8 by 9. This is your final answer. Okay. So now the next thing where we use this dot product. The next thing where we use dot product is to find the projection. To find the projection of vector v1 on vector v2. Okay, let's say there is a vector v1, this is vector v1, this is vector v2. So this part is called as a projection, like from vector v1 to vector v2. This part is called as a projection of v1 on v2. It is given as projection of v1 vector on v2 vector is equal to v1 dot v2 upon mod of v2. Okay, जिसके ऊपर प्रोजेक्शन होता है, like अगर V2 पे प्रोजेक्शन है तो वी डिवाइड दिस विद द मॉड ऑफ V2. ओके, अगर प्रोजेक्शन V1 के ऊपर है देन वी डिवाइड विद द मॉडुलस ऑफ V1. So projection of V1 on V2 is V1 dot V2. It's a dot product only. हम dot product ही कर रहे हैं. Divide by mod V2. सिर्फ mod से divide करना है. Okay. So for example, in this case, if you want to find the projection of V1 dot V2, V1 on V2, so we will find V1 dot V2. V1 dot V2 in this case was what? In this case it was 8. So projection of V1 on V2 in the previous example is 8 upon mod V2, which is 3. In the previous example, in this example, projection of V1 on V2 is V1 dot V2 upon mod of V2. So it comes to be 8 by 3. Okay. So this was a basic example I've taken. Keep in mind जिसके ऊपर projection हो रहा है उसके मॉडुलस से डिवाइड करना है. Okay. Now the last concept which we are going to take is cross product. Cross product of two vectors. Okay. The resultant in this will be a vector, so it is also called as vector product. It is also called as vector product. Let's understand how to find the vector product. V1. Let's say V1 is again A1I plus A2J plus A3K. V2 is B1I plus B2J plus V3K. So now we have to find V1 cross V2. It is given as determinant of. If you don't know how to find the determinant, I'll explain after this in a particular example. Determinant of A1, A2, A3. Here I have written the components of vector 1. After that B1, B2, B3. Here are the components of vector 2. After solving this, you will get a resultant as a vector, and that vector will be a cross product of V1 cross V2. Okay. Keep in mind resultant vector which will be obtained by cross product will be perpendicular to both V1 vector and V2 vector. So you have to keep in mind whatever vector we are getting after a cross product, that vector will be perpendicular to both V1 and V2. Okay. So whenever required to find a vector which is perpendicular to both, so you have to do a cross product. Let's take an example. Okay, Krishnu, I hope till now it is okay. Through example mostly you'll be able to understand. First of all, let's write V1 vector which is 3i minus 2j plus k. This is just an example. V2 vector which is 4i plus j minus 2k. So let's find the V1 cross V2 vector. So it is given as determinant of I, j, k. Now let's write the components of I, j, k here of V1 vector. It is 3, then minus 2, and then 1. Here 4, j component is 1, and k is minus 2. Now we have to find this determinant value. How to solve it? See, first write the I. And then don't look at the row and the column of I. Okay, you have this 4 numbers left. I into this entire part. Which part? Minus 2, 1, 1, minus 2. Then write negative j. And now don't look at the row and column of j. So you have these 4 numbers left. 3, 4, 1, minus 2. Then write plus k, the third element. Now don't look at the row and column of this element. You'll get 4 elements left. 3, minus 2, 4, 1. Now I into. You have to solve this as a cross multiplication. I'll just write it again over here. Minus 2, 1, 1, minus 2. So first you multiply this one, you'll get 4. Minus, then you multiply this one, you'll get 1. So which is 3. Minus j times. Minus 6, minus 4. Minus 10. Okay. Minus 6, minus 4. Now k times 3 minus minus 8. So what is left? 3i plus 10j plus 11k. This is the resultant vector of v1 cross v2. Okay, this is the resultant vector of v1 cross v2. Now where we are going to use this cross product, let's write those some basic applications. Okay, along with that, let's write the node points of a definition of a cross product. So 2 node points, let's write over here. So v1 cross v2 is defined as mod of v1 mod of v2 sin theta n cap, where n cap is a unit vector perpendicular to v1 and v2, is a unit vector perpendicular to v1 and v2. Okay, mod v1 is a modulus of v1, mod v2 is a modulus of v2, and sin theta. Theta is the angle between v1 and v2. Second node point. Mod of v1 cross v2 is given as mod v1, mod v2, and sin theta. So mod of n cap is 1, so we'll write 1 over here. So no need to write 1 also. We can erase this part. This is the mod of v1 cross v2. Third node point. If there is a triangle with vector A and vector B as a adjacent vectors given to you, then the area of this triangle is given as half of A vector cross B vector. Okay. Area of this triangle. Similarly, if there is a parallelogram given along adjacent vectors as A vector and B vector, in this case the area will be here, no half will be there. Okay, directly mod of A cross B. I'll just erase this part. Mod of A cross B. Done. This is the given modulus or the area of the parallelogram. Similarly, let's add one more point. If a parallelogram is given, instead of giving an adjacent side, let's say diagonals are given. Let's say diagonal d1 vector is given and d2 vector is given. So in this case, the area of parallelogram will be it is half of d1 cross d2. Okay, here the information is different. They have given diagonals instead of the sides. So the area in this case will be half of d1 cross d2 and the modulus of that. So this is where we are going to use cross product. Till now I think you have understood very well. Let's take an example and let's find the area of a triangle using cross product. Let's say a triangle is formed by 3, 2, 5 coordinates are given. then 5 1 4 other coordinates are given, and the third coordinate is given as -1 3 0. So these are the three vertices of a triangle given, A, B and C. So to find the area of triangle, we are going to use the cross product of our two vectors, okay, which is AB vector and BC vector. How to find the AB vector? It is B minus A. The concept of position vector, it is C minus B. So let's write the AB vector first. AB vector is B minus A. 5 minus 3 is what? 2i. I minus 2 is what? Minus j. 4 minus 5 is minus k. This is what we have got as a AB vector. Now let's write the BC vector, which is point C minus B. So minus 6i plus 2j and minus 4k. This is what we have got as BC vector. The area of this is what? Area will be half of mod of AB cross BC. Okay, so let's write the AB cross BC. I, J, K. Here instead of second row, we'll write components of AB. This, okay. So let's write this one now. 4. This is -1 into 4. 4 minus minus 2, which is 6. Then minus j into -8 plus 6. -8 minus 6. -8 minus 6 is what? -14. Okay. So this part again, -8 minus 6 minus 18 minus 14. K is what? 4 minus 6 minus 2. So k into -2. So 6i plus 14j minus 2k. So the area is what? Area is half of modulus of this part. So modulus of this part is 36. Square of this 14 square is 196 and the 2 square is 4. So 236. Area is half of 236 root. Okay, this is what the application of cross product is. I hope whatever we have covered today will help you to understand the basic concepts behind the algebra of vectors, addition, dot product and cross product. So I'll end this session over here. If anyone is willing to take a plus subscription, they can use my code RMSIR. There are huge benefits of plus. Okay, 3 live sessions are there. You have a live session, you have a doubt clearing sessions. After, along with that doubt clearing, top educators are here to guide you, live test series and many more. Okay, so I'll stop here. I'll end this session, and if again anyone willing to take a subscription, you can enroll with this code. Thank you.